Do you know that line was said in every movie? All right. Yeah, take it down. Okay, and then to clarify yesterday, I guess a little bit. That little process that we did to narrow down the divisor so that we got the letters M. M is how many things we have to give out. So the representatives in our consistent example I've used throughout all of the different methods was that 18 million people get 300 representatives. That was just a process to narrow down a divisor so I give out 300 on the dot. And we're going to do the same thing here again today. So from what I understand Webster's method to be is there's only one difference, and it's actually in the first line. This is different in all of the things we've done so far. What's different? What do we see up there? First step says round what? And that means round mathematically, like as a mathematician would be doing it. But we're going to do the same thing as far as how we start narrowing down if we don't get 300 on the dot, like that example we had yesterday and all the other examples. We're going to still use Jefferson's method, but this is how Webster sticks out like a sore thumb. It's the first time you've ever done that. So that means, if you got like 1.5, now we're going to round that up to 2 actually. We're not going to always round down. And then all this other stuff here, this is just about, I'm going to clarify this. The words really don't work out for me. I'll clarify it when we actually go into this first Mickey Mouse example, which isn't the state or the country that we've been dealing with. I will end with that country, though, again. Blah, 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 blah. So we're going to modify the divisor the same way we did with Jefferson's method. That's D1. And then after that, we're going to use a process to narrow down what would be the best divisor in order to give out M amount of things. For our example of that state or that country, 300 has to be the number that we give out perfectly. This next thing that we're going to do is a little different. So I'm not sure the words really work out for you. They are kind of tough to disseminate in your mind, I guess. I don't know if that's the correct word. This is an English. Good. Now, again, like I told you, silly question, but just to put numbers in there, just to go through a process. Students often say, "Why do I care what's going to happen with Spanish classes?" Right? Just to get the process down. And then the actual, that's why I like keep coming back to that example, because the example of the 18 million people with 300 seats, that emulates what happened with the United States and the practicality historically, how these things happen. And I found it interesting because I never knew anything about it. So anyway, yammering on about this as you take these down. I'm going to zoom in on this because the first part is actually the same step that you do in every single situation. I know you're trying to write down the notes as we go, so it doesn't matter that I'm speaking slowly. So we have this many students for these sections of classes. When we talk about 7 sections, that might be 2 teachers. One teaches 4 sections, the other one teaches 3 sections. That's really what they do there when they do a schedule for teachers. I have 3 sections of discrete and 2 sections of cat. Meow. Now, adding these up, this is 206. All right, so what we do is take 206 divided by the amount of sections that I have, and this becomes our divisor. And then again, I'm going to do this whether it bores you or not, because I really think you're silly if you have a graphing calculator and you're not using this chart format or the list feature. Now, I'm going to keep this L1 as it is because I'm going back to that example. You remember that? If you can see that far, I know it's hard to see, but that's the example where, of the 18 million, with 300 seats. I don't want to lose those numbers. So what I'm going to do is go to L2, because I can. Don't hit delete. Hit clear. You know what? I'm going to hit delete once. Watch what happens. It's okay. Well, look at. Oh, I'm going to hit delete. Ah! What happened to L2? It disappeared. Oh, let's delete them all. Let's kill them and crush them. Let's go get away. I hate you. Boom. Oh, now what do I do? Everything's gone. Now, what I've just taught is, what if this happens to you? I hit delete. Darn it. Now what do I do? Go up to this name. Watch what happens when I hit L1 back in here. L1, enter. Oh my. I didn't even lose the numbers, right? So that's all I got to do. L2, enter. I deleted that list. You don't know what this was. This is from the notes earlier today. You know, those numbers come out. So I'll clear, enter, and now I have these empty, and I wanted the L1 to stay where it was. Fumble. Okay, so now we're going to take all these numbers. I already have the numbers here, but I just want to cover this again. And then for an Inspire, you just open up a list spreadsheet. And then you can do all the stuff in your chart. And it's really about the same thing. I'm sorry, wrong. I need to type these in because I wanted to keep L1 alone. So I'm going to use L2 for this list. And this is an option. Just make sure you know where you're at and who I'm dividing. So now I'm going to go to L3 to do my work, but I'm going to divide L2 by the number that I need to. Where's L2, by the way? It's above what? 2. So there's second 2. There's L2, if you can see that little thing on the computer. And I'm going to divide that by this divisor, 29.43. Press enter, and then you see the numbers right on that list already written. 2.34, 2.17, 1.09, 1.39. Now, you don't get to see this. There is no difference, because what do all these numbers mathematically do anyway? What do all these numbers mathematically do anyway? They round down, so we don't get to see how Webster's different right now, because mathematically these round down anyway. But if this said, if this said 2.5, then this would be a 3. All right. Do I have only 6 sections? Yes or no? No. How many sections do I have? 7. Okay, so now, what do I got to do? I got to change this divisor so it's what? Bigger or smaller? If I change to a smaller divisor and I divide these numbers by a smaller number, what are these numbers going to do? Go up. And I want these to go up. So I think we need to understand that. So now what we have to do is do what Jefferson did first. And I do want to see this. We're going to treat this the same. Webster and Jefferson are the same on step 1. Who do I look at? 69, 64, 32, or 41? Hike. 69. And then what am I going to divide by? Am I going to take 69 divided by 2? We got a problem. We got all the wrong answers so far, right, somebody? What are we going to divide by? 69 divided by 2 plus 1. Because when we add to the denominator and divide, this decreases the divisor. And when I divide by a smaller number, all the numbers increase. Now, isn't this a significant change, though? So, okay, just emulate what we're doing in class. I think in realistic purposes, there might be something different that they go about. This is just a pattern that we can do. So I'm going to find I'm going to divide by this next. All right, so I'm going to go to my calculator. I was jumping ahead of myself. I'm going to go right on L3 again, because I don't care about that L3 list anymore. And I'm going to divide L2, because that's L2 right here, 23. And then this is the numbers I get. And you can see them on my calculator. Actually, let me get this in workable form that we can see both the calculator and those numbers. Okay, here we go. It's thrilling YouTube. 3, 2.78, 139, 178. What did 1.78 go up to, everybody? 2, 2.78, up to 3. Now we're what? Too big. Okay, now this is where you got to figure this out. I went from too small to too big. So what should the divisor be? Between. Somewhere in between these two, right? So one way you could do that is actually find the what of these two divisors? The average. So what I'm going to do is, because the first divisor I had not enough, the second divisor I had too many, I want to create a third divisor that's in between those two. This is just a method. Now, the other one was way off by 9. It looked like way too big. So probably should be a little bit closer to 29.43. But this is just a method to kind of narrow down what number is going to work. Okay, so now what I'm going to do is take the average of these last two. Too big, too small. Reverse that. I said that in reverse. All right, take the average of these divisors and now divide by that. L3, L2, divided by, simple math, 26.22. And then understanding that we're doing this so that all of these numbers, when rounded the way Webster does it, add up to 7. So we keep messing with the divisor until we get that to happen. And this is just one way to mathematically do that. Okay, so you see that on the list. Sorry, I keep messing up here. Now I'm going to shift down over here and show that next part and still understand that we're too many. So 2.63 goes up to 3. And 1.56 goes up to 2. These add up to 8. Aren't I close, though? Very close. So now you might do a little, thinking on this, but we're going to keep with the rote mathematics of this. Now, do I want to find the average between these last two divisors? If I find the average of the last two divisors and divide, what's my answer going to be between? 8 and 9. It's going to be 8 or 9 because of the way you round. Is that what I wanted to do? No, but what you did is you got closer and better. You got closer to 7 with this one. So I wanted to find the average of this divisor and Q this first one. Because then I'll get an answer between 6 and 8. I'll get 6, 7, or 8. So I don't, I think I kind of explained that in the video yesterday with Jefferson. I just want to make sure you understand that with this one. If I find the average of the last two divisors, you are bound to get an answer. No, not bound. That sounds like it's questionable. You will definitely get an answer that's either 9 or 8 again. Between 9 and 8. So what I need is the divisor that gave me 6 as an output and the divisor that gave me 8 as an output. I need the average of those two because I may very well hit 7 finally when I divide by that number. That's just simple math, folks. Okay, I've showed you how to do this on the calculator. Do I have to keep showing you that? Okay, no. I'll do it on the next one because it is hard not to use the calculator on the next one. But are a couple of them close to going up to the next notch? So this is when I divided by 27 when the divisor is 27.83. Who's close? The first one and the last one. Okay, so what do I need to do now? You could, quite honestly, keep going with this process. Who would I find the average of? 27.83 and who? Q again. This 23. So it's between these two divisors that actually work, right? I'm sorry, wrong. I said that wrong. This one, which is 29.43. So what we're saying now is the divisor has to be between these two. Because when I divided by 29.43, I got 6. When I divided by 27.83, I got... Wait, that's 6 again. I'm getting confused. I screwed up. Hold on. Let me turn off the video. This is awful. I stink as a teacher. Go to Twitter. I'm fine. What's between 8 and 6? What's between 8 and 6? 7. So I would, if I wanted to keep this process going, take the divisor between these two. My bad, dogs. Roof. Okay, so I'm done. Isn't this close? Isn't this close? Aren't we close? Okay, so at this point, I think, what do you think might work? 27.83, what do you think might work? 27.5? 27 point... I was thinking the other way. Because if I go too far, both of these are going to what? Both of these are going to go up, and then I'm going to be back to what? 8. 2 plus 6. That was that question. Okay, so 27 point... Actually, we found out in 5th hour, 27.7 worked. And now what did I do? I just went to my list, and then I divided by 27.7. Didn't work. 27.6, I believe, did. I'm not sure what I just said before there. So at this point, it's a guess and check. Knowing that I'm so close, knowing that I know how division works, knowing that if this just was 2.5, then this one would bump up. If this was 1.5 up, but I don't want both of them to bump up. I guessed and checked, and actually 27.6 worked. But I wanted to decrease it a little bit so that these increase a little bit. You understand that? That's why I went lower than 27.83. And then when I divided by 27.5, so this was a guess and check finally. I just said, you know what? I'm really close. If I keep doing this average, it's going to take too many steps to finally nail it. All right, and I'm just going to erase it. You know how to do it on the calculator. Finally, when I divided by 27.5, this moved out to 0.51, even though I just erased it. And this one stayed at 1.49, which we probably figured that would happen as we were doing this. All right. So at the end, this average process is just a way to narrow down what number actually works to get these outputs to be a sum of 7 using Webster's rule. As far as how you round is the only difference. Okay, so here's this example. All that stalled time of our little conversation we had, stimulating, right? Was to write this down again, right? And then at the end, I guess you could look at the posted notes online and see how this population of 18 million people with 300 seats, you do the different methods, you get different amounts of seats given out for representation. All right, so it depends upon the method, and things change and so on and so forth. What's the first change? Now remember, where does this 60,000 come from? I guess I didn't say that fifth hour. I think I did say it first, or I'm having we've done this. This is the fourth time we've done this question. I shouldn't have to tell you where 60,000 came from. So when and this was the notes from Wednesday last week. You take all these, divided by 60,000, you get the quota number in decimal form. And in all three of the other ones, what do we round? But what do we do in this one? Mathematically round. Mathematically round. Mathematically round. Round and round. Oh no! Shh! Silence back there. What do those add up to be? Well, I know no one will add it, so I'll do it. This is the first for the first time in forever. You get 301, which is too what? Too many. Okay, now this is I don't get this. What do we do next? Because this works like Jefferson. Who do we look at? A, B, C, D, or E? First of all, everybody. C. Okay, now what we got to figure out is this. What are we going to divide C now by so that we could get a new divisor? Now again, this is divisor 1, I guess. I don't really know how to write this. This is C's population divided by, now why 83 minus 1? Okay, so what's it going to do to the divisor? Make it what? Make it bigger, so the divisor will become bigger. So all of these numbers, when I divide by a bigger number, become what? Smaller, and may actually hit what? 300. So this is the math that you need to understand. The words are crap. The words aren't crap. They're just hard to work through to figure out what we're mathematically trying to do. And both Jefferson and Weber want to accidentally hit a divisor so that you get 300 in this particular case. If we don't accidentally hit that, then we got to find a process to find the right divisor. So the divisor must increase. What Jefferson and Webster accepted is take the largest states, change what you're dividing by depending on what you need. We need this to be smaller, so this divisor becomes bigger. So going to our calculator, this is one where we want to go out to the main screen. We take 4, 9, 6, 7, 0, 0, 0. Don't type 83 minus 1. What is that? And by the way, if you do this, this is wrong. Did you know that? No parentheses, you're not going to get the right answer. So that's another reason. I don't think I should have to cover that, but I do. I always say I shouldn't have to cover this, but then I do it. Okay, store X. Boom. I'm going to store it in X. I don't want to write that obnoxious decimal. Then remember what I said about my list? Stat, edit. Those not following along with me, I'm going to go back to L2, and I'm done with L2. I'm done with that last example. I'm going to make L2 now my numbers for this list. Now, if I ask you the decimals, and please do listen to what I say here, divided by x, you'll write the decimals, and I'll put to the hundredth, I guess. So I'd have you write 71.40, 43.5, 82, 50.2, 50.03. Okay, did I do that right? Okay, yeah, right. All right, so now what's 71.4 round to? 71, real rounding. Oh, right, I wanted to do this. Ah! Okay, 43.5, what does that become? What's 82 become? What's 50 and oh no, what happened? I lost 1, lost 2, lost 3, lost 4. What is this now a sum of? It's just 301 divided by minus 4, guys. 297, sorry. Yelling at the students. You okay over there? Focus, focus, hocus pocus. Now, what just happened? I don't think I need to see the question. Too many? Now that it's too short, and what if this was way too short? Way too short. And then the next one was way too short still. What do? I would keep at, right? Remember the +1, +2, +3? That's why we did that. And you have to look at previous examples. This one, the first check was too many. The next check was too few. Reverse that. No, that was right, the way I wanted to say it. So now what do? We want a divisor. Oh, I forgot to write this, by the way. I'm getting nervous because I know everyone's looking. Second quits, 6573. So our new divisor is 6573 with a decimal. So the first divisor was 60. The next one was 60,500. I got an answer too big and an answer too small. So what kind of divisor do I want? A divisor that's what compared to the last two? In between. So one way you could do that is find the average of the last two. And then we could do that on our calculator. Look, it's real easy. Grab plus 60,000. Divide by 2. And it is 60,286 between the other two. Well, of course it is. So now 60,286 without the decimal. Of course, what I'm going to do with this, stow x. And now I do. So this is both methods, Jefferson and Webster. The only difference is Jefferson always rounds down no matter what. Webster rounds up mathematically when it applies. But this process I'm doing right now is what you do for either one of them. Blah. Okay, so now what I'm going to do is hit Stat, Edit. Where is it? I'm getting all nervous now because I feel like the video is taking too long. L1, it is, they said. Youth of America. What's 71.7? 72. If I ask you to write the decimals, you write it, and you'll enjoy it. 44. 82.3, 82. 50.4 and 50.2. How many did I add compared to this one? Just one? And only one? Okay, now, here's where you got to figure this out. I can't help you mathematically. If you come up to my desk and say, I don't get it, you're missing the whole point. If I find the average of these last two divisors, what will my answer be when I divide that? Between 297 and 298. Is that what I want? No, I want to get what on the dot? 300. But what I did is I got closer to this one, right? Right? Yeah. So what do I want to find? The average of this one and 60,000. Because then when I divide by that average, I may get a number between 301 and 298, which may be 300. This is just, math thoughts. And and it should have been explained, I guess, this way yesterday. I think I tried to, but we didn't really have an example like this, I guess. Average of D2 and our first D, which is just the modified divisors have ones on them, I guess. Ones, twos. So D3 is the average of D2 and the original D. So that would be, second quit, 6286 plus 60,000. This is just simple math talk. And then when I divide that, this is between these two divisors, 6286 and 60,000. So when I divide by that, I should get a number between 301 and 298. Stow X. Boom. Stat. Edit. Sorry, Inspires. You haven't actually, your chart, your list and spreadsheets is not that bad to deal with. He said something nice about the Inspire. 71.92, there is something wrong. 71.92, 72. 43.8, still that 44. 82.5, what does that become? 83. 50.5, what does that become? 51 and 50. How many did I add from this previous list? 1, 2. Is it over? It's over. This is how we're going to do it. This is how we do it. What? That's